Hiya, my name is Mr. Baker, and today we're going to be looking at an application of refraction. We're going to be looking at lenses. So today we're going to be looking at lenses, or looking through lenses. So I'm going to tell you now that actually what you see is upside down. Our eyes are swapping everything over, and we'll explain exactly why that is in today's lesson. Okay, so have a look at these two examples of lenses. So you can see, so a lens is basically something that uses refraction, and remember, refraction is when light transmits through a transparent object and it changes direction, and we can use that property of light going through different materials and changing direction to make things called lenses, which basically do what we can see on these pictures. So we can see this lens here is magnifying everything, making things bigger. This lens here is making things smaller, and that's really what we use lenses for. We use lenses for making things larger or making things smaller. And we're going to look at the different types of lenses today, and we're going to look at why that is, and then I'm going to show you a little online practical as well that you can do. So there are two different types of lenses. Here we've got some different examples of them. You can have converging lenses or convergent lenses, and these lenses here look like this. They bend outwards like this, so when the light's coming through, they focus the light in, and these different ways that can happen. Divergent lenses do the opposite, so that when light comes through divergent lenses, they spread the light out, and either focusing the light in or spreading the light out can either make things bigger or smaller, and we can do that different amounts by changing how much we have these, how big the lenses are. If they've got a really big bend, they're going to change the direction more than if they haven't got a very big bend in them at all. So here's a couple of images of what's actually happening with the light. So here's some light rays, and remember, a light ray is just like one single bit of light that's coming through. So we've got some kind of light bulb or whatever over here, and the light's shining through, or it could just be light reflecting off an object and going through. And you can see that here all of these lines here are parallel, and then when they reach this lens here, they are changing direction. They're all refracting, and they refract towards the normal as it's going from air into glass in this case, and then refracting again when it comes out here, changing direction and focusing in on a point here on a converging lens. A diverging lens, the light here is parallel here, you can see, and then when it gets to the lens, the light spreads out. It goes through, because of the shape, the normal here is coming off 90 degrees from the glass, and that means that the light changes direction, still bending towards the normal, but because of the shape of the glass, it spreads the light out in this shape like this. Alright, here's a little online investigation that you could do. You can see that we've got a converging lens here. On this side we've got the object. So this is the thing that the light is coming here and it's reflecting off this object. And then over here, this is where the image would form. So if we had a screen or something on this side, then we'd be able to see an image on that screen because of the light reflecting off the object, going through the lens, focusing at a point, and we would see an image. And so you can see here, this arrow, instead of physicists being amazing artists, we tend to draw diagrams. And so this is a diagram of the object, which just is drawn as an arrow. So the arrow shows you the height, so it's a scale drawing of the height of the object, and it's also showing you which direction it is. Is it upright or is it upside down, which we call inverted? Okay, so that's the things to look at. And so what you can do is you can change the distance. So the object distance is the distance from the object to the lens, and the object height is the height of the object, so that's not going to change. The actual height of the object is not going to change. And then we can have a look at what happens to the image distance. So how far away is the image from the lens, and how far away is the how big is the image as well. Okay, so let's have a look. So we can change the the object distance. So it's gone from 200 to 180. And then we can see what would happen to something like the image height. So we could do an experiment to say, how does the object distance, how does the distance from the object to the lens affect the height of the image? Now it says minus 7.69, and it says minus because actually it's not pointing up, it's pointing down. So it's an inverted image, and this is what happens with converging lenses. So as the light comes in, the image that's formed is upside down. So if we went back to the beginning, our object distance was 200, our image height was minus 6.67. If we go to 180, if we can do it, the image height is minus 7.69. If we go to, let's go crazy, let's go to 100, the image height is minus 20. And now you can actually start to see this image. It looks like an arrow. It is an arrow. It's just pointing in the opposite direction, and it's showing us the height there. And then we could change the distance a little bit more. We could get it closer, and we could see how that affects the image height. So you can do this experiment by going to this website, which is physics.bu.edu, and then lenses. And what you can see, and maybe what the most important thing you can see from this, is that actually the object, although it's upright, the image is upside down. And that's really important when we're trying to answer this question that I posed to you at the beginning, or I told you that the whole world is upside down. And it's actually because of the type of lens that we've got in our eyes. Okay, so we'll leave it there, and I will show you the last thing. So here's a couple of images, a couple of pictures of a human eye, and you can see that the lens in an eye is a converging lens. So here's our object, and the light is being reflected, so the sun's coming and reflecting the light off a tree here. The light is then going to our eyes, going through the lens in our eye, a converging lens, and it's going through and it's focusing somewhere in our eye and creating this image here. And you can see the image is upside down, and the image is upside down because that's what happens with a converging lens. So this means that our eyes are actually seeing everything in the world upside down. So how come we don't see everything upside down? Well, actually our brains are really clever. So you can see here the image is upside down. It's being the light is being detected by eye, and then that goes to the optical nerve. The optical nerve goes to the brain, and then the brain flips it back to the normal way, or to the way that the world actually is, and so we can see everything the right way up. So that's it for today. That's looking at lenses and how we use refraction as an application. I've been Mr. Baker. Thank you very much. I'll see you next time.